Dear one and all, Namaste one and all. Okay, now let's we begin with module 3 part B of our analog electronic circuits. The subject code is BEE-303. Okay, the module 3 part B title is feedback amplifiers. Feedback amplifiers. Okay, we actually discussed it in the module 2 and module 3 about amplifiers. Here we are going to discuss it about feedback amplifiers. Okay, extra term is feedback. What do you mean by feedback? There is normal communication. Here we are going to, what are the general term about feedback? We are going to take some feedback. We are going to take some feedback from uh, students, from teachers. We are going to take some feedback. Na? Here also same wise, we are going to take the feedback of the amplifier to the uh, that feedback we are going to feed back to the same amplifier. Output of the amplifier, we are going to feed back to the same amplifier. So that is nothing but feedback through feedback network. So that is why it is named called feedback amplifier. Okay. Now let's we check the textbook definition. What do you mean by this feedback amplifier? The amplifier in which a part of output is sampled means output of the amplifier, the part of the output is sampled first and fed back to the input of the amplifier is called feedback amplifier. Whatever the output come from the amplifier, I am going to sample and fed back to the same amplifier. Input of the amplifier is called feedback amplifier. I am going to show the block diagram how we can sample and fed back to the normal amplifier. Okay, next, what are the different types of amplifier? Then what are the different types of amplifier, students? Here we have two types of amplifiers. What are those two types of amplifiers? Students, we have positive feedback amplifier, types of feedback amplifiers. In that, the first one is positive feedback amplifier, and then second one is negative feedback amplifier. What do you mean by this feedback? Positive feedback amplifier means when input signal and part of the output signal are in phase, then it is called, then the feedback is called positive feedback or feedback signal added with the input signal. This I am going to show with the help of some expressions. Okay, whenever the feedback out feedback, whether it may be voltage or current, feedback output voltage, you can take example output voltage add with the input voltage, then it is called positive feedback. If in case subtract in output voltage is subtract with input voltage, in that time it is called as feedback signal subtract with input signal, that is called negative feedback. Another definition, when input signal and part of the output signal are out of phase. In the positive feedback, in phase, positive. And out of phase means it is a negative feedback. Okay. What are the applications of this positive feedback? I hope all of you understand about positive feedback and negative feedback. I'm going to show in-depth analysis about positive feedback and negative feedback with the help of some expressions and block diagram. Students, now let's we understand the applications of this positive feedback and negative feedback. Most of the application, 99% of the, sorry, 90% of the application, we are going to use the same negative feedback, but positive feedback we are going to use in oscillators and Smith triggers. What do you mean by Smith trigger? Whatever the input we are going to give into the Smith trigger circuit, it will going to give the square waveform. So that is called Smith trigger. So in both the applications, oscillator and Smith trigger only, we are going to use the positive feedback amplifier. About negative feedback amplifier, we are going to use in only amplifiers. Most of the applications are amplifiers only. 90% of the applications, we are going to use negative feedback only. Then what are the features of this positive feedback and negative feedback? Next, let's we check it out. Positive feedback means it increases the output, useful only for oscillator. How it is going to increases the output? Let's we check with the expressions in the future slides. Okay, second advantage or features is overall gain is very high in the positive feedback. In the negative feedback, drawback is overall gain is very low. How it will going to very low? I'm going to show in the next slide, future slides. Okay, now just we understand the definition, advantages and disadvantages. And another advantages of this Negative feedback advantages. Drawback is only overall gain is less, but advantage bandwidth increases, reduce the noise, stability is good, more linear in operation. Students, now let's we analyze how it is how we can differentiate this positive feedback and negative feedback. Okay, students, now now all of you understand this is one of the block diagram, general block diagram of our, for better understanding. I wrote this block diagram here. This one is this round shape is nothing but shape, whatever it is there, it is nothing but a mixer. Okay, mixer. Okay, mixer. This is nothing but a normal amplifier. This is nothing but a output, students. This is a normal general amplifier. But here I'm going to use general amplifier. How we going to represent? This is how I'm going to represent. What are the parameters we need to write in the two-port network? Oh, I, VI, VI, II, VI, II, VI. This one is the amplifier. Here V naught, V naught. Here what is there? I naught. V naught and I naught, VI, II. Okay, students. Now, but it is a normal amplifier. But here, what is the extra term? Here I'm going to use feedback, feedback. So how we can give the feedback? How we can connect? So output of the amplifier, I'm going to connect to the feedback, and then this feedback output, I'm going to connect to the input of the amplifier with the help of this mixer, this mixer we need to write here. Okay. Yes, students. I hope all of you understand what do you mean by this feedback. Now, now let's we understand what do you mean by this R? R is nothing but a reference input signal, and this E is nothing but a error signal. This B is nothing but a feedback signal. This C is nothing but a output signal. I hope all of you understand. Now, now let's we let's we take down. Let's we understand. I hope all of you understand the block diagram. Now I am going to explain the detailed analysis of this feedback amplifier. Students, what do you mean by this R, C, D, E? Already mentioned. Negative feedbacks are very much useful. Already 90% of the applications we are going to use negative feedback. Students, E, E is equal to R plus B. How we can write down E? E is nothing but E has two inputs, R, B, whether it may be plus. If in case positive feedback amplifier, we can take plus. If in case negative feedback amplifier, we need to take minus. So what is the equation, students? E is equal to two inputs for amplifier, reference, first one reference signal, plus B gain signal. This is nothing but a positive feedback amplifier. Next, 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 next. How we can write E is equal to R minus beta. This is for negative feedback amplifier. This is for negative feedback amplifier. I hope all of you understand what you mean by this positive feedback. This is a negative feedback. In case we take positive, this is nothing but a positive feedback. Here, if in case take negative, that is called negative feedback amplifier. What do you mean with this error? Error signal. E is nothing but a error signal. Okay. Now let's we take some example to understand this negative feedback and positive feedback topology. How we can understand with the help of one small example. All of you guess there is one refrigerator or any eating device you have. So I'm going to give input as 30 degree like this. 30 degree R. This is nothing but a reference signal 30 degree B, and the feedback is nothing but a 35 degree. Don't take down this. This is not required. I'm going to check the what is the error signal. E is equal to, if in case we consider E is nothing but a error. That is not should be high. Okay. So E is equal to R plus B. What is the value of R, students? R is nothing but 30 plus B is nothing but 35. What is the total? 65 degree. Error is more in the feedback amplifier. So that's why we are not going to use much in the application. So that's why we need to move on to the negative feedback amplifier. So why E is equal to R minus B. What is the value of R? 30 minus 35 is equal to minus 5. Compared to this value is very low. So that's why we need to take negative feedback. So therefore, error is less in negative feedback. So this is how we need to understand the feedback amplifiers. In the feedback amplifiers, we have two types: positive feedback amplifier and negative feedback amplifier. Okay, now let's we move on to the next topic. What is the next topic, students? Next topic is next topic is very simple, students. Concept of feedback. Concept of feedback. What we understand, very basic understanding about feedback. Here there is a block diagram of about complete feedback network. Dear students, all of you, please check it out. Please check it out, students. Uh, all of you check it out. Very simple concept of feedback. Here there is a source signal input and mixer or comparator. In terms of block diagram, I represent. Okay, basic amplifier, sampling network, output voltage. From the sampling network, we need to take the feedback network, and that feedback we need to apply to the mixer. Okay, mixer. This is the overall explanation about block diagram. What are the terminologies are there here? Let's we check it out. A, first check take down. A is nothing but a basic amplifier. Beta is nothing but a no, beta is nothing but a feedback gain. A is nothing but a amplifier, normal amplifier gain. Okay, next Vs is nothing but a supply voltage. Vi is nothing but a input voltage. V naught is nothing but a output voltage. Vf is nothing but a feedback voltage. I hope all of you understand about this concept. Okay, now let's we move on to the next slide. Here that beta is nothing but a feedback gain. That feedback gain is varies from 0 to 1. What do you mean by this 0 to 1? Students, if in case take down, what is the feedback gain here? How to calculate gain? I hope all of you understand what do you mean by gain. Gain is nothing but what, students? Gain is nothing but I'm going to write the expression for gain. All of you understand what is the expression for gain, students? Gain is nothing but output divided by gain. For example, G gain is equal to V naught ಅಥವಾ output divided by input. Here, what is the output here? What is the output here for this feedback? For this feedback, I'm not going to calculate A. Here, I need beta. This is nothing but a gain, feedback gain. What is the output voltage for beta? VF is the output voltage. VF divided by V naught. What will going to come? VF is equal to beta V naught. VF is equal to beta V naught. VF is equal to beta V naught. Students, all of you observe here. I'm going to take beta varies from 0 to 1. Okay, if in case beta is equal to 0, no feedback. Why, students? Beta is equal to 0 ತಕೊಂಡ್ರೆ VF is equal to 0 ಬರುತ್ತೆ. Why? VF is equal to beta. Substitute here. 0 into anything is nothing but VF is equal to 0. If in case beta is equal to 1, 100% of input feedback. Why? Beta input is equal to 1. Beta is equal to 1. Substitute here. VF is equal to V naught. So 100% feedback is there. If in case beta is equal to 0.5, 50% of feedback is 50% of output is feedback or feedback. So that's why here what will be there? 50 percentage mean VF is equal to 0.5 V naught. Okay. So VS is nothing but a source voltage. VA is nothing but a mixer output. VF is nothing but a feedback signal. V naught is nothing but a output of the system. Okay, students. Now let's we rub the board. Okay. Next, now let's understand what are first block. What is the first block here, students? What is the first block? First block is what? First block is source signal. Now let's understand how we can represent this source signal. What are the different types of signals are there? Current signal, voltage signal. For now, let's understand how to represent this current signal. This is how we need to represent the current signal in terms of Thevenin theorem. Okay, Vs Seriously, RS. VS is nothing but a supply voltage. RS is nothing but a internal resistance of this supply or source resistance. That's how we can call. Then current source. This current source I'm going to represent like this. RS. We should write parallel to the this control current source. Okay, RS. IS, RS. Here VS, RS. Two types of current source. Now let's move on to the second block. That is nothing but a comparator. Comparator is a device. Comparator or mixer, both are same. Comparator block or mixer block is a device which compares two or more signal. Why two or more signal? Here we are going to give two signals, alva. What are the two signal? VF and VS. Feedback signal also, VS signal also. Here now comparator will going to compare two signals. What are all those two signals? VF and VS. VF and VS. VF and VS. Students, now, if in case I'm going to consider VS and VF, that is nothing but a voltage signal. IF also we can consider for voltage amplifier and current amplifier. That concept I'm going to explain in the future slides. The output is what? VI. The comparator output is what, students? VI. VI like this. VI. Okay. Now let's we understand. Dear students, what do you mean by positive feedback? Add positive feedback only. We are going to take VI is equal to VS plus VF. For negative feedback, VS here minus VF. Positive feedback, negative feedback. In-depth analysis not required. Here this diagram is nothing but a op amp. Op amp is nothing but it is a for 8-pin IC, 741 IC, 7 is nothing but VCC, 4 is nothing but VEE, 6 is nothing but output, 3 is nothing but not non-inverting terminal, 2 is nothing but inverting terminal. So you can take VI is equal to VS plus VF for positive feedback, VI is equal to VS minus VF for negative feedback. Okay, students, now let's understand how to represent these signals. Two types of signals already there, voltage signal, current signal. If you want to compare voltage, comparator is in series. If you want to compare current, comparator should be in parallel. Okay, students. Now let's understand how to represent this voltage. Compare now we know the compare voltage. Comparator should be in series. How to represent this one series like this? Already inform you like this. You need to write like this. Series VS and RS in series with the this amplifier. So this is how you need to represent VS, RS, VI, VF, V0. Okay. Now current signal parallel, not on a theorem, IS, RS, and then here we need to take feedback. We need to give this feedback to the amplifier parallelly. Okay. Now let's move on to the next one. Transfer ratio on gain of a basic amplifier. Basic amplifier is nothing but what? A is equal to X naught Xi. Why I need to consider X here? It may be voltage or it may be current. If in case voltage, you can take V naught divided by VI. VAV is equal to V naught divided by VI for voltage amplifier. AI is equal to I naught divided by II for current amplifier. RM is nothing but what? Trans resistance. Resistance means what? Resistance gain. How to calculate? Divided is equal to output divided by input. What is there in the output? Resistance formula we know. R is equal to V by I. Here output side, what is there? Output side voltage is there. So voltage is nothing. Resistance formula V is equal to V divided by I. R is equal to V by I. Output side V naught, input side II. GM. GM is nothing but what? Vice versa of our resistance. So that's why GM is equal to, GM is nothing but a conductance, vice versa of our resistance. Ulta. Okay, GM is equal to current divided by voltage. Here what is there? Output current divided by gain. Output current divided by input voltage. That is nothing but inductance amplifier. Okay, next, sampling network. Sampling network, if in case we need to sample the voltage, that is nothing but a voltage sampling network, current sampling network. Okay, voltage sampling network, how to represent in the sample side parallelly. Current amplifier series in terms of series. So this is the main difference between mixer and sampler. So you need to understand very carefully. For mixer, if you want to compare voltage, we need to connect in terms of series. But if you want to in the mixer, if you want to measure current, in that time we need to connect in terms of parallel, shunt or parallel. But in the voltage sampler, in the output side, sampler where is there? It is there in the output side. For voltage sampling, we need to connect parallelly. For current sampling, we need to connect series. Okay. Now, what do you mean by this feedback network? Feedback network we represent in terms of beta. Beta is nothing but output divided by input signal. If which case we need to take voltage, that is nothing but V naught VF divided by V naught. But in here, I'm going to take X means whether it may be voltage or it may be current. So that's why XF divided by X naught I already taken. So, Agidre, what is the advantages of this negative feedback? Normally, high input resistance of a voltage amplifier can made higher. Normally, low output resistance of a voltage amplifier can made be higher. The proper use of negative feedback improves frequency response of amplifier. Negative feedback stabilizes transfer gain. Negative feedback reduces frequency distortion. Noise output is reduced by a factor. Those are significant improvement in the literal linearity of operation of the feedback amplifier compared with the amplifier without feedback. So these are all the advantages with feedback. There is some disadvantages also, but these are all the advantages about feedback with negative feedback, especially negative feedback. Okay, okay, students. Now I'm going to stop this class. Next class, I'm going to explain next topic according to syllabus. I move on. So please be very carefully and understand the concept. Uh, from this concept for feedback amplifiers, you can score 10 marks in the examination. Okay, okay, students. Thank you.